Okay. So the formulas you can use are this formula or this formula. All you need to know is if you have sine A on the top, sine capital A, then you have to have sine capital B on the top over here. And then little a on the bottom, little a on the bottom here. Or little a on the top, little b on the top, sine A on the bottom, sine B on the bottom. So your signs have to be on the same side. So either in the numerator or in the denominator. Okay? Capital letters always represent angles, and angles are always beside the word sine. Little letters represent sides. The sine law is a relationship between the sides and angles in a triangle. Let triangle ABC be any triangle where A, B, and C represent the measures of the sides opposite angle A, B, and C, respectively. Then you can use either of these formulas. I always just stick to one version myself. You can flip between some, and some are a little easier if you do sides. I don't think so. All it is you're going to end up cross multiplying anyways. And you're only going to use two of these fractions at a time. You're never going to do this equals this equals this. You'll either pick these two to be equal or these two to be equal, etc. So to use the sine law, you must have an angle with its opposite side and another piece of information. So you must have an angle with its opposite side and another piece of information. So you need to have a side angle pair. To use sine law. You need to have a side angle pair to use sine law. If you don't have a side angle pair, you're going to have to use cosine law. So today, obviously, you're going to always have a side angle pair. The other thing you need to remember is all angles add to 180. To 180 degrees. So some people assume, hey, I don't have a side angle pair because I have the side and the two opposite angles, so I can't do sine law. Remember, if you have two angles, you can instantly find the third. 180 minus those two angles and get the third angle, right? So if ever you're given two angles, always find the third right away because you're probably going to have to find it in order to solve anyways. Okay? So if you're given two angles, always find the third. If you're interested in the proof of how this formula came about, you can look at the investigation on page 100. And the proof is on 102. Okay, let's look at a triangle here. It's a non-90 degree triangle. You can't use SOHCAHTOA. You can't use Pythagorean theorem. The moment it's not a 90 degree triangle, and the moment it's not a 90 degree triangle, you can't use SOHCAHTOA and you can't use Pythagorean theorem. So people will try and use Pythagorean theorem. Remember that the R value or your hypotenuse is always across from the 90 degree angle, correct? There is no 90 degree angle. Therefore, there is no hypotenuse. Therefore, you cannot use the Pythagorean theorem. So no SOHCAHTOA and no Pythagorean theorem when the graph or when the triangle is not a 90. So the first thing we always check for is, do we have two angles? No. If we had two angles, we'd find the third. The next thing we check for is, do we have a side angle pair? Because if we have a side angle pair, we're going to use sine law. Always. Okay? So I'm going to label first. This is angle B. Across from angle B is side B. So I write little b equals 6. Angle A is 110. Across from angle A is side A, which is 9.4. This is angle C. And across from angle C is little c. Okay? So I don't know the third side. I cannot use Pythagorean theorem to get it. I don't know what the hypotenuse is because there isn't one. Okay? However, I can use sine law. Let's see what it's asking us to find. It says, use the sine law to determine the measure of angle ACB. So when they give you letters like that, that just means you're finding the middle angle. You're finding the angle ACB. So that's angle C. That's this one here. The angle in the middle of the letters is always the angle you're finding. Now, why would they do that? Why wouldn't they just say find angle C? That's what everyone always asks. Well, what if I gave you a triangle like this instead? Whoa, whoa, bad triangle. And this is C, right? And I ask you to find C. Do you find the whole thing? Do you find the little piece? What do you find? So if I label these A, B, and D, let's say, if I say find angle ACB, then I would be asking you to find this little one. If I say find angle BCD, I'd be asking you to find this little one. If I ask you to find ACD, I'm asking you to find the whole thing. So that's why they label it with the different letters, okay? That's the reason. Now, let's go back to this one. So I know I have a side angle pair. I know I'm going to be using this one no matter what. I know in the end, they want me to find angle C, right? The only way I can find angle C, though, is if I know side C. Do I know side C right now? No. So what am I going to have to do first? I'm actually going to have to find the other angle first because I know the side across from it. Get that angle, subtract from 180, and I'll get angle C. I don't even need little side C, okay? So sometimes you actually have to find a different thing first in order to find what they're asking you to get. So I know I'm going to write this one first. I like putting sine on top, so I'm going to go sine A over little a, because personally I like doing that. And I'm using, bless you, sine A over little a because those are the side angle pair I have. So I'm going to have to use that first. Then which other one am I going to do? Well, the one with the side, 6, which is B, right? So now I'm going to do sine B over little b. The only way you can use the sine formula, you guys, the sine law formula, is if you're missing one thing. If you're missing more than one thing, you can't. So I can't go sine A over little a, sine C over little c, because I don't have big C and I don't have little c, so I can't use that, okay? You can only be missing one thing, so we have to use the B one. So now I fill it in. Ooh. Okay. Capital A is always the angle. So I have sine 110 degrees over little a, which is 9.4, equals sine capital B, I don't know because I don't know the angle, over 6. So ultimately, am I looking for an angle or a side right now? An angle. If I'm looking for an angle, the only way I find that is I'm going to have to do sine inverse. Remember, if it's a side, you're just be able to plug in all your stuff and you get an answer. If you're looking for an angle, you're going to have to cos inverse or sine inverse or tan inverse, right? Always. So we know in the end that's going to be our last step. So what do we have? We have a fraction equals a fraction. And what did I tell you guys you do whenever you have a fraction equals a fraction? Cross multiply, which is what everyone wants to do so bad. So yay, we get to do it. Okay. I always put the side first. So we have 6 sine 110. Could I have done the other one first? Yeah, it doesn't matter. Just pick 2 of them. So I always put the side length first. So 6 sine 110 degrees equals the other 2, 9.4 sine B. You could put the angle first, but I find when people put the sine first, they might not put an extra bracket behind the 110 when they put in their calculator, or they will forget they can divide. So that sine B is attached. That sine and B are attached right now, right? The sine goes with the B. So some people will try and just divide by 9.4 sine, get B by itself, and they think they're golden. No, you can't. That sine and that B are attached. So you actually have to divide by 9.4. And now you have sine B equals 6 sine 110 over 9.4. How do I get B by itself? Yeah, divide by the inverse of sine. So we're going to have B equals sine negative 1 of 6 sine 110 over 9.4. Now everyone has to practice plugging this in their calculator. What I do myself is I go 6 sine 110, hit enter, divided by 9.4, hit enter, and then go second sine, second answer on my calculator. If you have one of the fancy pants calculators, the new ones, check if you can arrow up. If you have the TI-84s, the black ones, or a different color, TI-83s cannot do this, but TI-84s, some of them you can actually press the arrow up and it'll arrow up your screen. Look if you can do that. You can just, so what you're going to do is second sign and then you'll hit enter over your answer and it'll insert it for you. It's wonderful. If you have the TI-84s, the new ones, you can go second, once you get your answer, you can go second sign and you can arrow up to your answer and hit enter on it and it'll insert it for you. It's wonderful. Okay? If you have one of those calculators, you can arrow up to all your information before if you want. Some of the TI-84s don't have that. This one doesn't. I can't. Even though it looks like a TI-84 that has it, it doesn't. I can't arrow up. So if you're one that doesn't have that, you're going to go 6 sine 110. Oops. 6 sine 110, enter. Divided by 9.4, enter. And then I go second sine, second negative sign. That little negative sign, because behind the little negative sign is the answer key. And it'll put your answer, your last answer in for you. So second sign and then second negative sign to get your answer. And then second sign, second, that. And it puts your answer in. There you go. So what did you get? 36 point. So 36.9. So 36 point, what was it? Give me 3 decimal places. 36.855. Okay, you need at least this many decimal places because you should not round until your very last answer. Normally, I would make you keep all of the decimals because that is not our answer. Our answer is, what do they want? Angle C. And we only want to round at the very last answer, right? This isn't actually the answer they wanted. They want angle C. So we know that this is 36.856 degrees. How do we get C? Subtract from 180. Once you know 2, you can just subtract from 180. I get 33.144, and you always have to look, it says to the nearest degree. So 33 degrees. You can round on your very last step, but please do not round before then. Especially if it's a numeric response. If you round before the last step of numeric response and your answer is 1 decimal place off, you're not getting it. It's wrong. Especially on the diploma, it's wrong because it just goes through a machine like this and it just marks it. So it won't say, oh, I'm sure they just rounded once and it's 0.1 and I'm sure it's really close and I'll just take it. No, the machine has no heart. Okay, it has no love for you. It's just and it's done. Okay. All right, next page. So this makes people cry a little when the triangle's not drawn for them. Okay? Don't let it. It says here, a surveyor measures a baseline. So I'm going to draw myself a baseline, PQ. It doesn't matter if this is perfectly accurate or not, guys. You're still going to get the same answer. PQ, 440 meters. Okay? He takes a measurement of a landmark R from P and Q. Does it matter where I draw it? Does it matter if I draw the R over here, or the R above, or the R down here, which makes no sense because it's a baseline, but would it make my triangle wrong? No. Draw an R somewhere. I want it to be here. Now, is it the most accurately drawn graph or triangle? I'm so used to graphs. Triangle? No. So if you look at it and you're like, the angle's 120, but it looks like it's only 13. Yeah, you drew it. Don't worry. You just drew it wrong. But that doesn't matter. The angle can still be correct. Okay? If you want to draw it a little more accurately, you can. Angle QPR is 46. So it's a little more than a 45-degree angle. And PQR is 75, so it's a little less. Hey, Hey, that was a random guess, and it was almost accurate. Pretty good, yeah? Does it matter if you were out to lunch? No. In the end, unless I was like, I'm going to mark your diagram, then yeah, I guess it would. It wants us to calculate the perimeter. Well, the first thing we want to do is label it and put everything we know. PQR, and then I always go, little p is across from capital P. Little q is across from capital Q. Little r is across from capital R. You label those. Then we label our angles. So we have Q, P, R is 46. So this is 46. And then we have P, Q, R is 75. Now, because you only know sine law right now, you're like, and we're doing the sine law lesson, you're like, well, we're obviously using sine law. But if I gave this on a test, you'd be like, we have to use cosine law. We don't have a side angle pair. So what you have to remember, you guys, is when I have two angles, what's the first thing I always do? Find that third one, you guys. We obviously have to use sine law. It's in the sine law lesson. But once I teach you cosine law, people will try and do cosine law with this. Always find that third angle. 59 degrees. Now we have a side angle pair. Our side angle pair is R. And you're going to forever use that side angle pair. Why? Because even if we get a new side angle pair, it's one that you found. There's a chance you messed up with it. So you want to always use the side angle pair that's given to you. So I'm going to use sine R over little r. Now it wants the perimeter, so all the way around the triangle. Okay? So eventually I'm going to have to find P and I'm going to have to find Q by using the sine law. Because even if I know two sides, there's no Pythagorean theorem of non-90 degree triangles that works. You're going to have to use sine law for the rest of them. So you have to do sine law twice. So sine R over R, and then I'm going to do P first just because I feel like it. Bless you. Sine P over little p. So sine R, capital R means angle, and angle always goes beside the little sine word. So sine of 59 over R is 440. And yes, you could use the other two angles once you find a side, because technically we found 59, but it was the easiest one to find, right? And then sine P is sine 46 degrees over little p. We don't know. And we know we did it correctly at this point because we can only be missing one letter, and we are. We have only one variable. Then we just cross multiply. What's the great one about this one? I'm finding a side. I'm not going to have to second sine anything. Because when you're looking for an angle, you have to do the inverse of sine, right? When you're looking for a side, you're just going to plug in, you're going to go. So we still cross multiply. We go 440 sine 46. You can do the other one first. It doesn't matter. I always like writing my side first. And then P sine 59. And remember the sine 59, that sine is attached to the angle always, so I can just divide it over. If you try and put this whole fraction in at once, you're going to have to put the numerator in brackets. If you're someone who's not the greatest with brackets, just find the numerator, hit enter, and then divide it by sine 59. Then you don't have to worry about brackets. And you know you can go 440 sine 46, hit enter, get an answer, right? And then just use a divided sign and it'll pop the answer up for you, right? Divided by sine 59. 623.156. I'm going to go over here and side P is 623.156. Decimal 156. And then we're going to do the other one. So I'm going to use sine R over R again. So I'm going to use sine R over R again, and then sine Q over Q. So I get sine 59 over 40, 440, equals sine 75 over little q. Oh, that's sad. Let's just see if my calculator's in radian mode. Radian mode got me. It got me. It got me mad. Got me bad. Yeah, well, radian mode made it be from 396.7 down to 316. Then I divided by sine 59. 369.251. Ah, radian mode. It makes a huge difference if you're in radian mode. So when you go to your unit test or your final and you come to me after and you're crying and you're like, I left it in radian. Don't come crying. Just put it in degree mode. You will cry though. Like, okay, this is the hint. If after the fourth multiple choice you are not even getting close to the answers that are on it, think, am I doing this completely wrong for every question? Or perchance could there be another reason why all of these are wrong? Oh, degree mode. Yes. People will come to me after the unit test. They're like, I was getting everything wrong and I didn't know why. The hint should be that maybe, perchance, you don't have it in the right mode. Okay?
They won't have common error for multiple choice. That's like common error in radian mode.
Grade 12 would, but we're not as mean. There you go. So we're going to get Q sine 59 degrees equals 440 sine 75. Divide by sine 59. And Q equals 495.828. Now, you should ask, is it reasonable? The larger the angle, the largest angle should have the largest side length across from it. The smallest angle should have the smallest side length across from it. So let's see if that makes sense. No, I still have that 600 there. See, if I kept the 600 there, I would catch myself at this step, because if this is 59 and this is 440, 46 should have less than 440, and I said it's 623, which makes absolutely no sense. So always make sure if it's reasonable. Go back when you're done and check. So this is the biggest angle. It should have the biggest side length. It does. This is the next biggest angle here, 59, and it's 440, then 46 and 369, so it makes sense, okay? So I always check at the very end, is it realistic? Now the perimeter is just adding up those three sides. So the perimeter is 495.828 plus 440 plus 369.251. It's the nearest meter. 1,305 meters. Okay. You guys try this one. PQR. If it says triangle PQR, I just go PQR. I know it's not the best way to go about it, but I find that some people will sit on a test for hours just being like, I don't know how to draw it. Please don't let that be the reason why you sit there for 17 years. Just draw something and work with it. It's not perfectly accurate, not the end of the world. Okay? Try it. So we can't find little r straight, our angle r straight off like right away because we don't know side r. So what are we going to have to do? We know angle P and angle P and side P, so we have a side angle pair. We know side Q, so we're going to have to find angle Q and then subtract from 180. And then just subtract from 180. Angle R equals 180 degrees minus 36 degrees minus 33.683 degrees. 110 is the nearest degree. 110 degrees. Now let's see, does it make sense in some ways? 33 is smaller, so side Q is smaller than side P. Makes sense. R we don't know, but it makes some sense. Okay, your homework is going to be down here at the bottom, below this diagram. Numbers 1 to 5. Just going to see if I want you to do part. You can do numbers 1 to 5, B and D where possible. B and then D where possible. So some of the questions only have A and B. You'll do just B on that question. And then if it has A, B, C, D, you'll do B and D. Okay?